Welcome, explorers. Whether you've watched for years or just stumbled upon this archive, where we document the stones that history has carried across oceans, but never brought home. We reveal verified accounts of gemstones found in shipwrecks, concealed in compass boxes, or stitched into the hems of sailors' coats, not for trade, but for protection. Some stones were selected not because they shone, but because they shimmered differently in salt air. They weren't meant to bless a voyage. They were meant to confuse something ancient. From Viking longships to colonial schooners, these stones moved without a map, passed between the captains in silence, feared by crews who swore the water watched them back. This episode features 10 gemstones once carried by sailors to confuse sea demons, not for superstition, but because storms weren't always what sank a ship. Charts redacted, ship names erased, but the stones remain. If this is your first time visiting the archive, feel free to leave a like and subscribe. Now let's begin with the 10th ranked stone. Ranked 10th, Iceland Spar, the stone that split the sky. This was not fantasy. In the 1960s, historians began revisiting medieval Icelandic sagas, which describe Solarstein, a sunstone used by Norse seafarers to locate the sun during fog or twilight. The sagas never named the mineral, and for decades it was dismissed as a poetic invention. That changed in 2011 when a team of scientists demonstrated that Iceland Spar could indeed determine solar direction with accuracy, even under thick cloud cover. The stone's optical polarization aligned with the light's angle in the sky, offering a low-tech but high-precision tool centuries before the invention of the magnetic compass. It wasn't sacred, it wasn't marked. It didn't glow when wet or sing when touched. It was clear, angular, and cold. But for nearly a millennium, sailors believed it could see the sun even when they could not. Iceland Spar, a transparent variety of calcite, is best known today in mineralogical catalogs for its optical properties. When light enters the crystal, it splits into two rays, a phenomenon known as birefringence. To the modern eye, it causes words or images placed beneath it to appear doubled. To Viking navigators, it did more. It revealed the position of the sun in overcast skies, even long after the horizon had vanished. But the stone's role wasn't limited to navigation. In ship logs recovered from later centuries, French corsairs, Dutch merchant fleets, even British whalers, sailors refer not just to sunstone, but to mirror rock or doubler. These weren't used on deck. They were kept sealed in leather. Some entries mention them only in storm reports. One English first mate, in 1798, wrote that the twin shadow crystal lost its edge the moment their heading began to drift. No coordinates, no latitude, just an implication. When the stone no longer split the light correctly, the sea became strange. Historians now believe that Iceland Spar, by the 18th century, had become more than just a tool for navigation. It was a test, a way to gauge whether reality was behaving as it should. And among superstitious crews crossing waters where compasses spun and stars vanished, that test became a last line of defense against something they could not name. In Norse cosmology, the sea was not a void. It was a presence, capable of thought, wrath, and distraction. To bend its attention away from the ship, they needed something that confused even light itself. They called it a guide, but they treated it like a shield. Rankne, Abalone shell, the fragment that distracted the sea. In oral histories passed through coastal tribes from California to Hokkaido, there are stories of creatures following the hull, not for prey, but for recognition. By the 16th century, Japanese fishing boats carried small charms known as awabi no tama, abalone slices wrapped in string, dipped in salt water, and hung from the stern. European whalers too carried abalone, though rarely in open display. In one Portuguese log from 1723, a helmsman wrote, "The shell pieces shake when the water grows loud. I do not touch them. They turn themselves." The idea wasn't to deter them. It was to confuse them, to give them something to look at, to reflect their vision on them. It broke easily. It dulled quickly. It wasn't precious in weight, nor was it rare in trade. And yet, for generations of coastal sailors, it was never discarded. Abalone shell, with its thin layers of nacre, carries a shimmer that bends with movement. Iridescence, they called it, though for most mariners it was known by a simpler term, sea glint. In low light it flashed. In full sun it rippled. But under the cloud it pulsed, neither blue nor green, but always somewhere between. Early Polynesian navigators in the Pacific embedded pieces of abalone into the prows of their canoes, angled not for decoration, but for reflection. In Maori watercraft, abalone inlay was carved into figureheads facing forward. Gleaming eyes meant not to see, but to be seen, and not always by human eyes. No one called it magic. No one believed it gave safe passage. But when waves sharpened at the edges and fog came from the wrong direction, sailors would shift the abalone just slightly on the hull. Historians remain divided on whether the use was symbolic, superstitious, or purely aesthetic. But what remains certain is this. These weren't stones for guidance. They were diversions. Because in many sailing traditions, the sea didn't always attack from below. Sometimes it was watched, and sometimes it needed to be distracted. They called it sea glint, but they placed it like a mirror. Rank number 8, sea opal, the color that refused to settle. In 16th century colonial reports from the Gulf of Mexico, Spanish officers described indigenous fishermen who refused to cast nets unless their opal shell fragment shone clean. One Jesuit priest dismissed it as pagan ritual, until his ship turned back during a calm, just hours before a storm sank another vessel ahead. It didn't stay one thing for long, not in light, not in water, not in memory. What modern collectors call sea opal often refers to hydrophane opal, a porous form of the mineral that appears pale or milky when dry, but transforms instantly when it comes into contact with moisture. Its structure absorbs water, shifting from a ghostly white to streaks of blue, green, violet, even crimson, depending on the trace minerals in the environment. Some versions found in coastal cliffs or river mouths are fossilized mollusk shells that have been slowly opalized over time, under pressure and through the chemistry of seawater. Among sailors, its value was not aesthetic, it was behavioral. In Polynesian navigation traditions, opalized shells were set into ceremonial paddles or fastened to hulls, not for steering, but for signaling. In oral stories from Vanuatu and Tonga, there are references to stones that turn red before tides change, often interpreted as spiritual omens or as pragmatic tools to sense mineral shifts in water long before weather can confirm them. Later, Dutch merchant fleets noted strange behaviors around what they called zeeoog, sea eyes. These were fragments of semi-translucent opal stored in sealed driftwood boxes. A 1681st journal entry reads, "It refused to glow. The cook said not to leave. The captain laughed. By morning, the mast was gone." By the 18th century, English whalers had adopted similar charms, but hid them, tying opalized fragments under benches or embedding them in deck beams. No sailor wore them openly. The logic wasn't luck, it was camouflage. The shimmer, they believed, could distract or deceive something unseen. Not all feared sea demons in name, but nearly all who spent weeks without stars, drifting where compasses faltered, accepted that something in the water responded to more than wind or tide. They spoke of currents that twisted without cause, of reflections that blinked back, and of colors that seemed to trigger silence or movement. Sea opal didn't answer, but it reacted. And for sailors raised on caution more than faith, that was enough. Today, hydrophane opals are sold in markets as a novelty, with little trace of the role they once played in maritime belief. However, in rare cases, divers report specimens that shift unnaturally when approached, brighter, then suddenly clouded, as if choosing not to be seen. Science calls it refractive instability. The sea, perhaps, calls it something else. They called it sea opal, but they never trusted it twice. Rank number 7, blue amber, the glare that looked back. On certain nights, the sea reflected light unnaturally. Waves shimmered in straight lines. Lanterns flickered with no wind. Some said the ocean was mimicking their signals. And when that happened, the blue amber came out. It wasn't used to ward. It wasn't used to guide. It was used to confuse. Held out briefly, then covered. Sometimes placed in shallow bowls of rum, the glow amplified into something that resembled a floating eye. A French privateer in 1749 recorded, "We faced no storm, yet half the ship refused to sleep." They said the water kept blinking. The boatswain poured rum on the stone. The light stopped. It didn't start blue. It started golden, like any other piece of amber, fossilized resin hardened by time and heat. But when exposed to sunlight at the right angle, it turned, not in hue but in effect. It glowed, not with color but with contradiction. A yellow stone that shone blue. Blue amber, found almost exclusively in the mountains of the Dominican Republic, is the result of rare molecular structures within the resin that fluoresce under ultraviolet light and high-intensity sunlight. The effect was unexplainable to early naturalists. But to sailors who passed through the Caribbean during the 17th and 18th centuries, the stone wasn't a puzzle. It was a signal, one that looked back. Crews departing from Hispaniola carried small polished fragments, some embedded into wooden charm plates, others wrapped in tobacco leaves and hung near the bow. Among maroon communities descended from escaped enslaved Africans, blue amber was believed to blind the second eyes, a phrase referring not to human vision, but to something beneath the waterline that watched with different rules. Modern mineralogists classify the glow as fluorescence caused by the presence of aromatic hydrocarbons. The stone's molecules absorb ultraviolet radiation and re-emit it as visible blue light. But for sailors long before spectroscopy, none of that mattered. The fact that it changed under scrutiny, that it seemed to notice light, was enough to assign it intent. In some ship traditions, a piece of blue amber was stored in pitch-dark compartments. If it emitted a glow without provocation, the crew changed heading. They didn't pray to it, they didn't name it, but they watched it closely because they feared it was doing the same. Today, blue amber is sold as a collector's stone, admired for its rarity and iridescence. But a few museum archives, particularly in Martinique and Saint-Domingue, still hold slates etched with instructions. Show the eye only once. If it answers, hide the hull. They called it blue amber, but no one stared into it for long. Rank number 6, mother of pearl. The reflection that broke the gaze. Among Polynesian navigators, nacre was set into the eyes of boat figureheads, not to guide but to disorient. On ancient Arab dhows, thin strips were inlaid into rudder heads and compass cases. Japanese ama divers carried slivers and woven cords, never as decoration, but as fragments that watch back. It wasn't rare, it wasn't mined, and it didn't carry the same weight in trade as rubies or coral did. But for those who lived and died by salt water, it was never called common. Mother of pearl, also known as nacre, lines the inner shells of mollusks, forming a smooth, iridescent surface that plays with light. Its glow isn't from pigment, but from microstructures that scatter and reflect wavelengths differently depending on angle and motion. For centuries, coastal cultures carved it not into jewelry, but into barriers. It was said the shimmer couldn't be followed, not by fish, not by man, not by anything that moved without sound. In 12th century sea scrolls preserved in Okinawa, drawings depict ships surrounded by circular glints, described as moonlight broken in water. But moonlight wasn't present, only nacre set around the hull. European seafarers picked up the tradition in fragments. English galleons began embedding mother of pearl into deck grates, where light would bounce irregularly at night. Dutch East India ships recorded sections of hull coated in crushed nacre paste, thin enough to flake, but broad enough to shimmer. In one 1612 log from a Portuguese vessel near Mozambique, the navigator wrote, "We passed the shoal but were mirrored twice. The sea blinked wrong. We turned not by compass, but by shine." By the early 18th century, mother of pearl found a second life as warding, not of evil, but of recognition. If the sea looked up and saw itself reflected incorrectly, it might lose interest. Or so the belief went. Some captains affixed nacre discs to ropes, letting them trail just below the surface like decoys. Others kept them tied to cargo, so the reflection would sink first, not the crew. Science today refers to it as angle-dependent reflection, which is explained by the aragonite plates layered in nacre. But the physics didn't matter to those watching the water change without cause. They didn't call it sacred. They didn't wear it on land. But they took it anyway. Not to mark the ship, but to blur its outline. Because the sea, they said, could track movement, but not mirrors that lied. They called it mother of pearl. But no one trusted what it showed twice. Rank number 5, Tektite, the shadow that took the blame. European explorers often misunderstood the black fragments as lava pearls or ballast debris, but they noted how local pilots grew visibly uneasy if one went missing. A French Jesuit in 1694 wrote, "The stone was dropped and the boy would not sleep above deck. He said the sea would now know our name. It didn't come from the sea, but the sea seemed to recognize it anyway." Tektite is a type of natural glass formed when a meteor strikes the Earth, heating and fusing terrestrial rock into irregular jet-black fragments. They carry no crystal faces, no inner fire, just matte darkness and pitted surfaces like hardened drops of ink. And yet these stones were passed from land to boat with careful purpose. In maritime cultures from southern China to Indonesia, tektites, known locally as lei gongxi or thunder god stones, were not kept for wealth. They were suspended, tied beneath the keel, or hidden inside hollow rudder frames. They weren't meant to reflect. They were meant to erase. Fishermen believed the ocean could misread a ship, confuse its shape with prey, mistake its movement for a threat, or become drawn to the echoes cast by the vessel's shadow. Tektites, they believed, absorbed false signals. They took the reflection and held it. A 15th century Cham sailing manual, recovered in fragments from the Mekong Delta, warns, "When the water glows but the moon is absent, bind the dark glass below the salt line. Do not let your true shape return upward." In other records, Thai coastal traders placed tektites in nets of bronze wire, lowered into the shallows before anchoring. If the water cleared too quickly or stayed still too long, they retrieved the stone first before touching the rope or hull. Science tells us tektite absorbs light with high efficiency owing to its glassy amorphous composition. But it doesn't reflect. It doesn't flash. It doesn't even look wet. And that was the point. To sailors who feared the sea not as a force, but as a thinking presence, bright stones attracted questions. Tektite answered none. It sat silent, black, featureless, an object too inert to betray, too unchanging to invite attention. They didn't carve it. They didn't name it. They just dropped it where the light bent wrong and waited for the tension to break. They called it thunderglass, but never after dark. Rank number 4, SeaGreen Serpentine, the shape that broke direction. Carthaginian sailors carved it into twisting forms, mimicking sea serpents or wave-locked eels. These were embedded into the hull near the bow or tied to ropes trailing behind the vessel. Not to ward off monsters, to confuse them. It didn't shimmer, it didn't pulse, it didn't shift under light. But it always drew the eye, because no one could tell which way it pointed. SeaGreen Serpentine, a translucent green variety of magnesium silicate, was shaped and polished across ancient Mediterranean cultures, not for trade, but for its protective properties. Not against weather or gods, but against something older. Something that moved without a pattern and was watched without sound. The stone's color, somewhere between shallow bay and storm algae, made it ideal for carving. It held curves, it held symbols, and more importantly, it held contradictions. Egyptian coastal traders believed serpent's green mirrored the eyes of what watches upward. The logic was simple. If a creature looked up and saw its kind, or something shaped like it but moving wrong, it would hesitate. Some would turn, others would drift, but none would strike immediately. In Phoenician shipping records from the 9th century BCE, certain captains were marked as holders of double shadow stone. These were licensed to cross zones known for vanished vessels, marked on nautical slates only by swirl symbols, not coordinates. A compass didn't guide them. They carried a stone that refused to keep pace with the rhythm of the waves. One Cretan legend, preserved in fragmented pottery shards, describes a stone figurehead carved from SeaGreen serpentine that pulled the current sideways. Whether metaphor or misreading, it reflected a belief that the stone didn't just trick the eye, it altered intent. By the 2nd century BCE, Greek mariners no longer questioned its use. They simply ensured one piece, no larger than a palm, was lashed beneath the oarlock. Smooth side facing down, carved side facing the hull. Modern geology identifies serpentine as a soft, layered silicate with low reflectivity. It doesn't bend light, it doesn't glow, but in choppy water, its green disappears into the wave shadow and then reappears, slightly off, like something swimming in the wrong direction. To sailors unsure of what followed them, that illusion mattered. They didn't trust it. They didn't show it to passengers. They just made sure it was cold before sailing. Because if it warmed too quickly, something was watching already. They called it sea serpent stone, but never by name and never when the sky was green. Rank number 3, Chrysoprase, the calm that wasn't yours. Greek texts from the Hellenistic period describe it as a stone of forgetting, not for memory but for intention. It was said to quiet the noise of internal conflict. Among coastal captains, this reputation became a strategic asset. If a crew member harbored dread, guilt, or ambition while at sea, the water would sense it and act. Chrysoprase was tied to the masthead, not to invoke protection, but to dampen signals. Emotional ones, intentional ones. Thoughts that made the ship visible. It looked harmless, cool, translucent, the color of shallow water on a still day. But sailors didn't keep it for peace. They carried it to hide the parts of themselves the sea might notice. Chrysoprase is a variety of chalcedony colored by traces of nickel, giving it its signature green, a tone that's neither emerald nor jade, but something closer to sea foam filtered through pale glass. It was easy to polish, easy to shape, and in certain places, it is too easy to misunderstand. A Byzantine admiral wrote in 842 CE, "We carried 3, one at the stern, 2 beneath the helm, not for the storm, for the men." In Phoenician cargo logs, Chrysoprase appears marked not under cargo or gem classification, but in the section reserved for obscuring devices. These weren't counted. They were kept, silent, pale, and cold. Arabian navigators near Zanzibar suspended chrysoprase beneath their hulls, encased in lead and thin silver. When the stone cracked, it was taken as a sign. The sea had already sensed them. No prayer would matter after that. Modern gemology classifies chrysoprase as a cryptocrystalline variety of quartz. It doesn't fluoresce. It doesn't refract. It holds light faintly, like a memory beneath skin. But underwater, especially in motion, its color begins to fade, replaced by soft shadows and shapes without detail. That was what sailors wanted, not to shine, not to vanish, but to appear forgettable. Some carried it near the ribs of the ship. Others lashed it to weapons, believing it dulled the attention of what lingered just below the hull. They didn't explain it. They didn't offer it. They just checked it each morning. If the color turned gray, they turned back. They called it the stone of unspoken thoughts, or simply the calm that wasn't yours to keep. Rank number 2, Larimar, the stone that stole the voice of the sea. A ship's boy aboard the Epine Noire in 1763 noted in a smuggled journal, "Captain placed the blue rock in the bilge again. Said it will tell us we're not speaking today." The waves softened by dusk. It didn't flash. It didn't shift. It simply settled, with the calm of something that had already spoken. Larimar, a rare blue variety of pectolite, is found only in one place on Earth, a small volcanic region near the Dominican Republic's coast, where the river meets the reef. Its soft blue and white bands resemble shallow waves frozen mid-motion. To the modern collector, it's prized for color. To early sailors, it was feared for silence. The Taino people, native to the Caribbean, referred to it as blue fire turned cold. It wasn't worn, it was placed, tucked into driftwood altars, wedged into ship keels, or dropped into tide pools before departure. It wasn't meant to protect, it was meant to interrupt. In oral traditions recorded by early missionaries, many of whom misunderstood or erased the context, Larimar was believed to absorb sound below water, muting the pulse of human motion. If the sea couldn't hear you, it couldn't choose you. That belief didn't vanish. It migrated quietly into the practice of marooned sailors, Caribbean traders, and even French corsairs who sailed through dead echo waters, places where sonar failed and hulls vibrated without wind. Geologically, Larimar's structure is fibrous, with minute air-filled channels that create a scattering effect. It absorbs more vibration than similar stones of its size. But for those who trusted the sea to listen, it was less about physics than presence. Larimar wasn't shown. It was embedded, hidden just beneath deck boards or behind prayer carvings. Some captains believed the stone echoed wrong, causing spiritual listeners to pass over, like a voice they didn't recognize. When the crew grew restless or the sea was too still, the stone was briefly submerged in warm water to wake it. If it remained cold, the course was changed, not by map, by mood. To those who believed Larimar wasn't an object, it was a decoy frequency, the audible lie that nothing here belonged. They called it sea sleep stone, and none ever dared call it out loud. Rank number 1. Moonstone, the light that moved the moon. It didn't glow, it drifted. Moonstone carries no fire, no brilliance, just a sheen, a soft, silvery movement across its surface, like something sliding just out of reach. This optical effect, known today as adolescence, occurs when layers within the feldspar scatter light. But to sailors, it was never about scattering, it was about redirecting. In coastal India, Moonstone was embedded in ceremonial anchors, never dropped, only dipped, during tides when the moon was full but felt off its course. Malay navigators passed them down, tied in silk. They weren't to be worn, only placed at the helm when the stars were wrong. The belief was simple. Moonlight was used by the ocean, by its creatures, and by the things that lived in its shadows. If you followed the moon, so did they. Moonstone was the only thing that made the moon unreliable. Ottoman maritime texts describe stones that softened the arc of light. They note ships that crossed narrow channels under moonlit skies without detection, while others, sailing the same path a night later, vanished. The difference? A palm-sized moonstone was sealed behind the mast. By the 18th century, Arab pearl divers refused to begin descent unless the stone had shifted. If its glow stayed still, they remained aboard. A diver from Muscat wrote in 1792, "If it drifts, we dive. If it waits, we stay. The watchers don't like it when light lingers." Moonstone is geologically inert. It doesn't emit. It doesn't reflect like glass. It blurs, turns defined beams into illusions. And when moonlight is your only compass, illusion becomes camouflage. Some captains placed the stone just under the waterline, so that the reflected moon shimmered in fragments. Others submerged it entirely, just long enough to turn the tide's attention. It wasn't magic, it was misdirection. And in seas where stars vanish and compasses spin, that's all they needed. They didn't pray to it. They didn't name it. They just looked up and hoped the moon they saw wasn't the one being followed. They called it tide glass and only ever touched it in silence. They weren't looking for beauty. They weren't carrying treasure. They carried deception. Because for those who sailed without maps, it wasn't the storm they feared. It was what waited just beneath calm water. What recognized movement? What is understood as light? And if a stone could buy a moment of confusion or cast the wrong reflection, that was enough. Today, these stones sit behind glass, filed under minerals, jewelry, or folk belief. But on nights when the tide changes without warning, some still check what's tied to the hull. Thank you for joining us in the archive. We'll see you in the following file.